So, Kez asks, what will the critical value be? That's what comes next. If you look in tables, you have those two probabilities, greater than or equal to 12 and greater than or equal to 13. Which one? What are we looking for in terms of these probabilities here?
Smaller than 5%.
Smaller than 5%. Yes, that's right. That is not smaller than 5%. This one here is smaller than 5%. So our critical value would have been 13. If we had seen 13 or more people cured, then we would have concluded that the new drug is better. Because it's a probability of 13 or more, it's the first probability that is smaller than our significance level.
I think you're reading on the wrong one.
12, I've got here is...
Yeah.
No, that's right.
That's right,
No.
because it's technically less than or...
That's right.
No.
Oh, there's some debate here as to whether these numbers are right.
Are you want to calculate?
N is 20, P is 0.4,
I agree with that.
0.
I agree.
That's coming from 9,435. That's on the 11 line. So less than or equal to 11 is opposite of greater than or equal to 12. I'm sticking with it. If you are looking at that in the tables, that in the tables is coming from less than or equal to 11.
Yeah.
So when I've done 1 minus, which is the opposite, that's the opposite of greater than or equal to 12. Okay?
Yeah.
Right, next bit of the question then, moving on. What is the probability of a type 1 error?
What's that?
Wrong answer, but glad you said it, okay? Somebody just said 5%. When you are dealing with discrete data, a type 1 error is not the same as the significance level. This is the new bit, okay? It only applies with discrete. So it says here, as x is discrete, and we've had to round to an integer to get the critical value, because in theory, if we were looking a minute ago, we wanted this probability here to be 0.05, well, we couldn't. It's somewhere between 12 and 13. But we can't go between 12 and 13 because we're discrete. So we haven't actually got a value that corresponds exactly with 0.05. So it's for that reason, as it's discrete and we had to round to an integer to get the critical value, the probability of a type 1 error is not the same as the significance level of the test. That bit there is a key point, okay? For discrete hypothesis testing, type 1 error is not the significance level. That is a key thing. That is why it changes with discrete stuff. That needs to be written down and got into your heads. So we need to go back to our definition. Well, what actually is a type 1 error? It's accepting H1, or in other words, rejecting H0, when H0 is actually true. That's the definition of a type 1 error. So we need to know the probability of rejecting H0. Well, we would reject H0 if we observed more than 13. That's when we would reject H0 or accept H1. And it said given H0 is true. Well, if H0 is true, that means P is 0.4. Well, we've already worked out that probability, or wrote it down. I mean, we saw it in the tables. That was the first probability that was smaller than 5% that we saw a minute or two ago. So that is the type 1 error's probability. That is the different bit when we deal with discrete data. Are we all happy with that? If we're happy with that, what do you think the next question I'm going to ask is?
What's type 2?
Yeah, next question. What's the probability of a type 2 error? If we're doing a type 2 error, we always need, well, type 2 error is the probability of accepting H0 given H0 is false. If H naught is false, we don't know what P is. All we know is P is not 0.4. We need the great god of statistics to tell us another number. There we are. The great god of statistics has told us it's 0.5. So, with that information and your knowledge of what a type 2 error is, can you see if you can work out the probability of a type 2 error in this scenario?